Hi guys, in this video we are going to discuss another interesting question about condition for stable equilibrium. Here they have given there is a block of wood of rectangular cross section of sides A and B and of length L, has a relative density of X. If the block is to float in water with its longest axis horizontal and the side B vertical, condition for stable equilibrium can be defined as. So we need to find what's the condition for floating this body in a water. So they have given some symbols too. Relative density of the box they have given as S. So we need to find what's the stable equilibrium condition. If you are new to the Expert Tutor channel, please don't forget to subscribe it. Also, we have already done many videos regarding fluid mechanics and basic fundamentals of engineering. If you like to watch them, I have given the link in the description, so you can always watch that. Okay, if you already knew what's the condition, please pause the video and try it in your own and watch the rest of the video and compare your answer with mine. Okay, let's start with first. So here they have already mentioned, so I have already drew a picture. If you don't know, please, when you are reading any questions, try to draw that, sketch that in a image so that you can easily understand and easily tackle that question. So they have given all the data, relevant data, so I have marked that in this paper. So here we are going to take, first of all we need to find what's the condition for stable equilibrium. Actually we knew that when you are considering that, you can directly tell the GM, the metacentric height of that object, should be greater than 0 for a stable equilibrium. Actually I hope you have already learnt about the metacentric height. I'm not going to touch in deep. If you don't know about that, please watch any YouTube video so you can easily figure it out what's meant by the metacentric height. Actually you don't need to remember what's meant by that, how they have given the equation. Actually it's enough to remember the equation. They'll remember the formulas to apply for the questions. So here what's meant by the GM is, if it's submerged in that or partially submerged, we can directly tell it's, if I draw this part like this, the B part like this, the total height, and let's say this is the water level on it. So from that we can tell, if this is the same part, this is the depth of that body, and this is the B part, the vertical part, vertical height of that. We can directly tell the center of gravitational point, which is we are denoted as G, is going to be inside this line. It's going to be in the middle of that because it's in the rectangle and it's going to be a very perfect body shape. So we can tell it's going to lie in this part from this OG. Let's mark it as O, and it's going to be in this G. The G, the gravitational center of gravity of that point, is going to be in the middle of this rectangle, so cube. So here you can directly find like this. If you draw a part, you can actually tell the center of gravity would lie on the middle point, but for this easiness we are going to draw in one line, like one line. So it's going to be in the B/2. So the next part is we need to find where the center of buoyancy will take part. Actually, if you are considering that, if you knew that it's having a depth of, it have submerged for the depth of D, we can tell it's also like a similar rectangle surface, so that we can tell it's going to act in the D/2 distance from the O. When you are considering about that, the center of buoyancy would be in the middle of the total depth. It's going to be at the D/2 distance from the O. So you can assume that. So from that we are going to mark it like this. Actually we don't know what's the value of M. It's okay. We need to figure the value of GM over here. So we need to find the GM. If it's greater than 0, we can tell it's in the stable equilibrium. The question is about the stable equilibrium, so we have already taken as that GM greater than 0. We need to figure it out, the answer for that. GM is greater than 0. Actually how we can write this GM is, actually it's, let's assume like this. We can tell we knew the OG, which is B/2, and OB, which is D/2. Now we can directly write it like this. It's going to be GM would be equals to OB plus BM, OB plus BM minus OG. If we consider that, it's going to return the value of GM. Actually, you can directly use this equation. It's the similar type of equation you are going to use in several questions. So it's going to be OB plus BM minus OG. Why we are using this BM is, actually we can find the value of BM. We have a formula for that. I'm going to show that in a couple of more methods. So OB, we actually knew that it's going to be B by 2. Sorry, it's going to be D by 2 plus BM minus OG, which is B by 2. Should be greater than 0. So the next part is how to find this BM. There is an equation for the BM. The length of the BM would be equals to I divided by V. You need to know what's meant by the I and V. When you are considering for these, let's draw. When you are seeing from the upward side, actually you can figure it out. It's going to be like this part. When you are seeing from the upside direction, if it's a water level, let's say this is the water level, it's going to be a little bit up. But when you are considering about this BM, you can tell that when you are considering about this I, you need to see from this water level. So when you are seeing from the upward side, you need to imagine from the water level, you can tell the surface would be like this, a rectangle. So I have drawn like in the sideways, it doesn't matter, but actually you can figure it out. It's going to be, I tried to draw it in the 3D image, that's why it's like parallelograms. The thing is, it's a real rectangle. When you see from the upwards, it's going to like the rectangle. So we need to find the second moment of area of that rectangle, but the question is whether to find from this side, horizontal side, or from the vertical side. So it would be, I think it would be easy if you think like this. If you see from the top, it would be like this part, and the question is, we need to figure it out from the second moment of area from the horizontal direction or the x direction or y direction. The thing is, you need to find, this is known as the rotation from this part is known as rolling, and this part is known as pitching. For this equilibrium, actually we knew that the GM would be the lowest if BM, so because if we are staying in the equilibrium, we need to make sure it's going to, the GM would be greater than 0 for both pitching and rolling. We need to make sure that if we take any second moment of area from any axis or any sides, it's going to satisfy GM greater than 0. So the thing is, we don't need to check for both these two. If we check for the BM is lowest, we can make sure it's going to satisfy for the highest two. So we need to find when the BM is lowest. So when we are considering about that, we actually knew that BM is proportional to I. So we need to figure it out when the I is lowest. Because the reason is, if we find if we show that when the I is lowest, and when the I is lowest, the GM is greater than 0, we can directly tell when the I is higher in these two, when the I is highest, we can tell directly that GM is greater than 0 for that too. So we need to show for I is lower position. So we need to find whether this I, when we are taking from this axis, actually we knew that I is going to be equals to 1 by 12 BH cube. This is the base for this axis and this is the H. So it's going to be lower. Let's say this is I1. If you take the second moment of area from this axis, it's going to be 1 by 12 into B, this length, into H cube, which means this length is very big. So that the second moment of area from this axis is going to be higher than this rolling axis. So we need to take the lowest part. So we are going to take this part, 1 by 12 in this part into H cube. So I'm going to write that I part 1 by 12 into B, the length, which is L over here, and the A cube. So we can directly substitute over here. So we are going to get 1 by 12 L A cube. and we need to divide it by the volume. Remember that it's the submerged volume. We can't take the whole volume of this body. We are going to take the submerged volume. Actually, we knew that it's going to submerge for the depth of d. So the volume of this whole rectangular, the submerged volume would be, actually we knew the cross section area of that is going to be L into A, and the depth would be D. So we can tell it's going to be LAD. If you write that, you are going, the L would be already cut out, and A, and there would be only two signs, A squared over 12D. So this is the BM value. So we have now figured it out, A squared over 12D, D by 2, B by 2. The last part, the final part is we need to find what's the value of D, what's the depth, submerged depth. You can easily figure it out by equating the upthrust force and the weight of this. So let's do that. Upthrust would be equal to weight if it's floating. So the upthrust force would be equal to the total, the V rho G. Actually, we knew that the V means the volume, the submerged volume. It's, we have already found it out. It's LA into D. So V into rho. Actually, we knew that when you are using the rho of the liquid's density, is going to be like rho. It's going to be the water, so you can directly write it as rho into B rho into G. Likewise, when you are considering whether the weight of this total cube, you can directly tell it's going to be the total volume of this part is going to be A into L into B, L A into B, into the density of that. It's going to be, actually we knew the relative density of that, it's going to be S, so you can directly use it's going to be S into rho into G. So if you simplify that, LA would be cancelled, and you are going to get D is equals to SB. So now we have figured it out, the relationship between D and B, because the question they haven't given the D value, so you can't express the final answer in the D. So that's why we have get a relationship for D and B. So now we are going to substitute all the values over here. So I'm going to use this D is equal to SB over here is going to be SB by 2 plus BM. We have actually find that it's going to be A squared over 12D, which is SB minus B by 2. So we need to solve that. So when you are solving that, we can directly take, let's I write it over here. We can take these B parts over in once B by in the next side. If I take, so I'm going to get B by 2 less than SB by 2 plus A squared over 12 SB. And the next part is we are going to take, so we need to check whether we have any equations over here. So what we can actually do is, yes, now there is another B, so I'm going to take this B over here. If I do so, B by 2 1 minus S squared over 12 SB. So actually you can even simplify this. If you bring this 12, if you can easily cut down this part, it's going to be 6xb. If you bring this SB in this side, you are going to get SB squared 6xb squared, sorry, 6xb squared into 1 minus x greater than a squared, sorry, less than a squared. So in other terms, you can, if you want, you can take this b squared in one side. You are going to get a squared over b squared, which is greater than 6s into 1 minus x. If you want, you can take the root of that, because actually we knew that all are positive values. So if you take the root, ab is going to be greater than root of 6s 1 minus x. It actually depends on the answer they have given in the exams, but here they have given in this form, so that's why we have taken for this form. I hope you have clearly understood this question. If you have any doubts, please comment it below. Thank you for watching.